Hello everyone, hope you all are doing well. So now we will start our new topic, that is calculation of energy difference between two energy orbits, frequency and number of waves in orbit. Previously we have done the calculation of energy of a single orbit. Now we will do the calculation of energy between two orbits. So let's move further. Here we are having energy 1. Here we are having energy 2 in two orbits. Energy 1 is equal to n21 and energy 2 is equal to n22. Now how n21 and n22? So likewise, here is a number of orbits, means two number of orbits, same in second one. It's the first one orbit and is the second one orbit. So that's why it's n21 and n22. Okay, let's move further now. That after that, here we have a formula that del E is equal to E2 minus E1. With this one formula we can find the calculation of energy difference between two energy orbits. Okay, so after that we will use the formula of total energy. Like we are having the formula over here of total energy, that is minus z square e power 4 m 8 epsilon naught square n, and here we have used the n22, means n22 means we are using the E2 energy, and n21 means we are using here first one energy. Okay, means number of orbits. So what we did, that we have put in over here number 1 and then minus sign of formula, then minus 1 second one total energy, then we will do minus minus, so multiply it will get plus, and after that we are having these two equations same, remain same. After that what we have done, that we have taken the common over here, that is minus z square e power 4 m upon 8 epsilon naught square h square with minus, and this is the value that remains common over here, common, and the remaining value when we again multiply with it, so we will get this one answer. Okay, now what we have to do, as we know that the total energy, we are having total energy value that was minus that was 2.178 into 10 to the power minus 18. So here is the minus sign, so we have also put in minus over here. After that these will remain same. Then we did the kilogram and per mole. We want kilojoule per mole, so we know the number of moles we have written here and divided by kilojoules. So if you didn't understand this one, so you can check out my previous lecture of chemistry. After that, when we multiply and divide this all, so we will get we have gotten the answer, that is minus 1313.315 kilojoule per mole. And here we have gotten that 1 upon n 2 power 2 minus 1 upon n 2 and 1. Now here is the n2 and 2 and n2 and 1. So here I said that we can find the two energy orbits. So wherever you can say in a problem, or in a problem they have written that they solve these both energies, so we will use this one formula to solve those energies, in which they have given us a first energy, that is n 2 power 2 value, and then giving us the second one value. Then we will just put this value over here in both this, and we'll get the answer of calculation of energy difference between two energy orbits. Next, our two topics, that is to find frequency of an orbit and to find number of waves in an orbit. So finding the frequency, this is the sign, or you can say symbol, to find the frequency. We will use our one formula, that del E is equal to Planck constant multiplied by frequency. This is the formula to find frequency in an orbit. After that what we did, that we have put in the value of the total energy, as we have put in the calculation of energy between two energy orbits. After that this is a complete formula of del energy to find the energy between two, that, and h Planck constant and frequency will remain same. After that what we did, h is multiplying over here, it will move over there and it will divide. So what we have did, let me show you. Like here was the h2, when this one h goes over here and divided with this, so it will multiply with this, so it's h3. Okay, h2 plus h1, we are having h3, and here we are having just frequency remains. Now what we have done, that we have put the value of these all, and after that we got the answer, that is the constant answer, that is minus 2906 into 10 to the power 15, and number of orbit 1 and number of orbit 2 is equal to frequency. To find the frequency of two different orbits, you have to use this one formula, in which we will put the frequency of number 1 orbit and number 2 orbit. After we will get the frequency with this one formula. Okay, now let's move further with to find the number of waves. In the number of waves, here's the same, that we have using this one formula, that is frequency is equal to, you can say, velocity of sound or velocity of light or speed of light multiplied by number of waves. What we have done over here, we have just changed the value of frequency, like we find over here a value of frequency. This was the value of frequency. So what we did, that we have put the value of complete frequency over here. After that we are having c, that is speed of light over here. When it's multiply over here, it will goes over there and it will got divided. So what happened, that the c come over here and multiply with this downward value, and this is the value, that the value just done with, that is, this is the formula to find the number of waves. And to find just the number of waves, we are having value, that is then we just did, we put the values of these all, and we got the answer, that is minus 1.096800 into 10 to the power 7. And here is again number of orbit of 1 and number of orbit of 2. Then we put this both value, we will got the number of waves in two different orbits. Hope you understand today's lecture. Thank you so much for listening.